All right, so I'm going to slide a box across the floor at constant velocity again, and I'm going to look for the value for the coefficient of friction. And I've got a 50 kilogram box being pulled with an applied force of 220 newtons at 32 degrees. Now, sometimes it's helpful to think about what I need to find in order to answer the question. So the question asks, what's the coefficient of friction? And in this case, coefficient of kinetic friction, because the box is moving. So mu k. And I know the formula for mu, for the coefficient of friction, is the friction force divided by the normal force. So in my solving this problem, I have to find the friction force and the normal force. So let's go and do my free body diagram. I have the weight force caused by the gravitational field of the Earth, so that's mg. Since the box is sitting on a floor or table, that means that floor is putting a force on the box, the normal force. And we're not in happy physics land, so there is a friction force that I need to find. So there's my free body diagram. I know I need to find the friction force and the normal force. And because this object is traveling at a constant, I know that this object is traveling at a constant velocity. I know that the net force acting on the object has got to be 0. Looking at my free body diagram, I can see that the applied force isn't in line with the other forces. So in order to be able to find the net force of 0, I need to break this applied force into its components, the x component and the y component. And I break that into its components using the cosine for the x component and the sine of the angle for the y component. I'm going to do that on a calculator. 220 cosine 32 gives me an x component of 186.57 newtons and a y component of 116.58 newtons. Okay, so now I've got my free body diagram completed. I can start trying to figure out what the friction force and the normal force are. All right, let's start with weight force. I can do that one because I know that my box is 50 kilograms times negative 9.81, 50 times negative 9.81. Not a decimal point. Negative 490.5 newtons is the weight force of the box. Alright, so now I'm ready to start going after the friction force and the normal force. I'm going to use the net force of 0 in order to do that, because I know this object is traveling at constant velocity, so I know it has a net force of 0, which means the forces in the x direction are 0, and the forces in the y direction have to add up to be 0. That's how I'm going to find the friction force and the normal force. The friction force is the easier one, because in the x direction, the two forces are the applied force and the friction force. So I know the applied force is 186.57 plus the friction force, which has to add up to 0. So those two forces must be opposite each other. So I know the friction force is negative 186.57 newtons. So I got my first half of my coefficient of friction, the friction force, 186.57. Now I'm ready to take a look at finding the normal force, which is in the y direction. But in the y direction, I have 3 forces making up the total in the y direction. I've got the weight force plus the normal force plus the applied force. All have to add up to 0. The weight force, I have negative 490.5. The normal force, and the applied force, or the y component of the applied force, 116.58. Remember the other day when we talked about friction? We said it's not the weight force that's important in determining the friction and the coefficient of friction. It's the normal force. Because the weight force can sometimes not be the only forces acting in the y direction. So we have to include any applied forces in the y direction, which may cause a change to the normal force. It's not going to cause a change to the weight force. It is going to cause that change to the normal force. All right, so subtract the 490, or add the 490, subtract the 116, and I'm going to get a normal force of 490.5 and 116.58. A normal force of 373.92 newtons. So my normal force, again, I like to be complete and make sure I get all the forces onto my free body diagram as well. 373.92, 373.92 newtons, which will give me the second part of my coefficient of friction, 373.92. Again, I didn't add the negative for the friction because that's the direction. And remembering that the coefficient of friction is a scalar unitless quantity. It's just a ratio between the friction force and the normal force. So being the ratio, it doesn't have direction. So I don't need the negative on the 186. So 186.57 divided by the 373.92 gives me a coefficient of friction of, when I round it off, 0.50 is the coefficient of friction. 0.5. It's 0.4989, so round it off 0.50. That's the coefficient of friction.